Lesson 3, topic, compare and order real numbers. Learning target, I can compare and order rational and irrational numbers. Perfect squares, we talked about this last lesson, but just a reminder of those perfect squares are squares of our whole numbers. So numbers, when they multiply together, that make a perfect square. So you have 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square, and so on. Let's fill in our square roots of perfect squares chart. We did this last class, but it's going to be a helpful tool for us as we work through our lesson today. So we are going to approximate or estimate square roots to the nearest whole number. So for today we're going to start with the square root of 7 to the nearest whole number. So the first thing we want to do is identify perfect squares closest to 7. So we're looking here, and we see that the square root of 7 would fall between the square root of 4 and the square root of 9. So it would be 4 and 9 would be the perfect squares closest to 7. Then we're going to take the square root of each number. So take the square root of 4, the square root of 9. And then we just need to evaluate those square roots. The square root of 4 is 2. And the square root of 9 is 3. So the square root of 7 falls in between the numbers 2 and 3. So let's try another example. We have approximate the square root of 73 to the nearest whole number. So again, identify perfect squares closest to 73. Well, if I look at my chart, 73 would be in between 64 and 81. We're going to take the square root of both of those. And the square root of 64 is 8. And the square root of 81 is 9. So that shows us where the square root lies between. The last thing we want to do is be able to get a closer estimate. So we just estimated the square root of 7 to be between 2 and 3. But we want to make a closer estimate. So we want to know, is it closer to 2 or is it closer to 3? So if we put our square roots up here, the square root of 4 is 2, and the square root of 9 is 3. 7 is a little bit closer to 9, so we could say it's closer to 3. So I know it's going to be somewhere on this upper half. But where in that upper half is what we have to check. So this is where our calculator is going to be helpful. So we're going to pick a number to start with. I'm going to start with the 2.7. So we're going to do 2.7 times 2.7. And we get 7.29. So we want it to be really close to 7 because we're looking at the square root of 7. So it's a little high. So I'm going to drop it down to 2.6. So let's do 2.6 times 2.6. And that's 6.76. So you can see that the square root of 7 is going to be between 2.6 and 2.7. So on our chart, we could put the square root of 7 between 2.6 and 2.7. So it would be about 2.65. Let's do one more example. We, on the last slide, said that the square root of 73 was between 8 and 9, between the square root of 64, which is 8, and the square root of 81, which is 9. So we want to get a closer estimate. So 73 is pretty close to right in the middle of 64 and 81. Looking at these numbers under the square root. So I'm going to check these middle numbers here. So I'm going to go back to my calculator. I'm going to start with 8.4 times 8.4. And we get 70.56, not quite 73, so let's move to 8.5 times 8.5. And we get 72.25, really close to 73. So I know that that 8.6 times 8.6 is going to be a little bit too high. So we could say that a good estimate for the square root of 73 would be 8.5. That is the end of your notes. You can move into your practice.